Hello, everyone. My name is George Rivera. We have a great webinar here for you to discuss the 7 secrets of better thermal image quality. And just some background, I'm an engineer and a sales manager for tequipment.net. We're an authorized Fluke distributor for many years. And joining me is Marco Rossi, from the category manager for the Americas for temperature and thermography, and Corey Glassman, a global training manager for Fluke. Gentlemen, are you with me?
We are, thank you.
Yes, we are. Good morning.
All right, great. Thank you for joining. While we're waiting for any late joiners, I just want to give you a couple slides about our company, T Equipment, and go through those, and then we'll turn it right over to Fluke. So here's just the first slide. Our company is 16 years old, and we're a large stocking distributor. We really do take to heart the slogan there at the top of the screen, buy from people, not just the internet, and we have a qualified staff here to help you. As you can see from the slide, we're a national and international distributor. We cover the needs of a pretty wide variety of customer categories on the left, and on the right side gives you some of the products. And we're going to be talking about thermography today. And then on this slide on the left side, you could see a screenshot of our website with filtering capability. We've invested pretty heavily on that function of our website, the searching. And on the right side, you could see a snapshot of an internal portal that we use to manage customer accounts. And we can assign tasks to different people so that things don't fall through the cracks. And we can also give timely information about tracking and so on right to the customer over the phone. So that just covers briefly what I wanted to talk about. And let me turn it over to you, Marco.
Thank you very much. Thank you very much, George. Hello, everybody. Marco Rossi and Corey Glassman from Fluke Corporation. We want to thank tequipment.net to give us the opportunity to present. So if I could have control, George.
Yep, I believe. I had to hit one more button. There we go.
Excellent. So here we go. Let me start presenting. Please confirm when you see my screen.
Yes, I see it.
All right. So thank you very much, everybody, for having us here, for attending to this 7 Secrets to Better Infrared Image Quality webinar. Again, my name is Marco Rossi. I'm the category manager for Americas in the TI and temperature group. I also have the pleasure to have here Corey Glassman, which is our global training manager. Corey has been in the company for almost 30 years. He started in the product management, product development, and now he's working with the North America marketing team. I've been with the business unit for 2 years, so just to give you a quick background. So let's jump very quickly into the agenda. And so before jumping in this type of webinars, before jumping into the 7 secrets, we want to spend some time and go through the basics and fundamentals of thermography. Why? What is a thermal image? How is it created? What is the true value behind a thermal or radiometric image, right? What are the typical applications? Then we're going to jump to the domain discussion, right? What are the applications, opportunities in multiple verticals? How can the inspections, the thermal inspections, can be added into your maintenance or PM schedule or program, right? Then we're going to jump into the 7 secrets of a good thermal image, right? And last, we're going to wrap up the conversation with some recommendations from Fluke. What will be the right infrared camera? What are our 3 families, and what are the price points that we're managing? So let's kick off with what is a thermal image, right? So thermal image is the graphical representation of a thermal energy or heat of an object, right? Since infrared radiation is emitted by all objects with temperature, thermography makes it possible to see an inspected object. And this is important, with or without visible illumination, right? And we're showing here right now on the right a coffee mug, right? Which is a visual image, correct? However, this coffee mug, the object itself generates heat, right? And the infrared image is actually the very same object, just containing thermal information, right? Or thermal condition of the object. And it allows us to see some things that we don't see visually, right? And let me show you how the coffee mug looks like, right? And this is a thermal image. This is an infrared image, which is basically the heat signature of the entire body. In this case, is the coffee mug. And the colors that you're seeing right now in the IR image are the measurement of the temperature of this object, the mug, right? Another thing critical to understand when using thermography is that each color on an infrared image corresponds to a different point of temperature, right? So in the coffee mug image, the darker the colors, the cooler is the image, while the close to red colors we have a higher temperature image, as the one that we're seeing right now, 60 degrees, the temperature of the coffee. And also, let's try to understand what is a thermal image, right? And I always try to explain this with the example of a pyrometer or of an IR gun, right? If we use an IR gun and map the temperature of an entire object on an area, we're going to have a grid of values that will look like this, like the array that I'm showing on the slide right now. And this will be what I call the thermal portion of the word thermography. Temperature values contained in an array. If we want to have this with a thermal gun, we need to sample an entire area and collect all these measurements. While with a thermal camera, we'll have this in a single image, okay? And that is actually what the thermal camera sees, right? It's a large array of values, right? Now let's go to the image from the very beginning. What is the image that we're looking for? We're looking at an electrical area, an electrical panel image, right? And we're inspecting it, right? Once we turn the image into radiometric mode, we have the opportunity again to see how the data is collected and converted into the graphical mode, which is the thermal side of the image, right? But we're also, with the visual representation, we're adding to the word thermography the graphy part. And here it is, a full infrared picture. And each color represents a different point of temperature on the entire image that we saw before. So now we can clearly see what is the difference or delta in temperature between what we saw visually and what we're seeing right now in infrared. And spikes in temperature, deltas or temperature signatures can tell us where do we have issues that we can tackle later using whether a power quality analyzer, a multimeter, or a VOM, or even a clamp meter. But always, the rule of thumb is that when we have a delta in temperature, which is higher than the average temperature of the image, something's wrong, and it's an indicator that we might have a malfunction on the system. So, in a summary, thermography is taking thermal data and visually displaying it as an image. Thermography. So, let's start by saying that temperature data gathered by thermal imagers and combined with the analysis capabilities is making these days significant contributions to preventive maintenance programs. And many of the segments that Fluke offers, not only thermal cameras, as well as multimeter, climb meters, most of these segments, they have preventive maintenance programs and they're adopting thermography on it, right? An interesting thing to mention here is that the ramifications of missing something that you cannot see, whether it's a thermal indicator, it's huge, right? So we might find questions about equipment conditions that are often raised by abnormal indications, as I mentioned before. Examples could be a motor bearing, which is significantly warmer, and obviously we cannot see that visually. So we need a thermal camera to detect the heat signature on the area, right? It could be also hot bushing or it could be also a tap in the transformer, right? Other assets such as MCCs, internal components failures, with thermal cameras, we should be able, through isolated heat signatures, to detect these issues through thermal indications, right? In R&D, PCB boards, in thermography, in quality assurance thermography, it's used for manufacturing and testing PCB boards, right? And this is another area where in process manufacturing, thermography plays pretty good. It's monitoring the solid levels in tanks, silos, and deposits, right? And this could be large assets, elevated deposit that contain any type of liquid, right? And all these issues can trigger a future equipment failure that can create a domino effect in the industrial system. And this will carry huge repair costs. I want to also speak about what are the verticals, right, where thermal imaging or thermography is actively used. One is process manufacturing and oil and gas. And these are in general the biggest serviceable markets that we have. And most of the applications are electromechanical or mechanics assets, and obviously besides the usual electrical equipment inspections. Motors here are thermally inspected because they're very susceptible to heat-related failures. And we're going to talk about this in a minute with some slides that we have. Same with electrical assets, but there are also some specific vertical equipments where thermography help also in troubleshooting in cement and food and beverage. And again, we'll see this later. We're going to talk about this. Utilities is also another vertical market where thermography technology is adopted, right? And in all three segments, right? Generation, transmission, and distribution. An interesting thing here is that the selection of the camera depends on the applications and the domain factors of that utility segment. So we have seen, for example, cameras used in generation, in the generation segment of utilities, and these are mainly used as troubleshooters, right? As industrial troubleshooters, very similar to what I mentioned in process manufacturing. While in transmission and distribution, thermal cameras are highly related to the inspection of specific assets in substations, circuit breakers, transformers, or even high resistance connections in transmission lines. So there's definitely a split line between generation and transmission and distribution. Other verticals such as pharma and R&D, we have seen cases of using thermal imaging for Q&A and bottling, seal integrity, or packaging phases in pharmaceutical companies, right? Also, I think I mentioned before, in research and development in semiconductors and electronics, thermal cameras are used for quality assurance. And so go on, right? We might find we might find thermography in more verticals, right? We can find it in academic electronic research. We can find it in aerospace, non-destructive testing protocols. So we're focusing obviously in process manufacturing, utilities, and discrete manufacturing, but we're seeing a huge growth in non-typical troubleshooting heavy industrial markets. And here are the slides I was mentioning before around cement, food and beverage. Let's talk about the applications, right? And one of the biggest applications for TI is the electrical sector or electrical systems, right? And most, or maybe if not all, faults in the electrical systems are usually resulted on a change in flow of electricity, also an overload in specific phases, right? And the common denominator here is that in the area where that problem is happening, whether we have an overload phase or we have a disbalanced problem, we'll see an increase of heat or temperature. And here's where the camera always plays, right? You can see here a couple of examples in substation applications. There's a high resistance connection, possibly due to corrosion. Here, there's another one. There's a connector above the bushing cap to the bushing rod that it's normally hotter, right? There's also on the bottom right area, there's a fuse, a center fuse, which is definitely having a problem, and it's an isolated issue, right? Which is telling us that thermally there's a problem, there's an indicator that something's not right. Let's also talk about mechanical or electromechanical. And electromechanical mechanical inspections cover a diverse variety of equipment. And most of the inspections in motor, rotating equipment, string traps, these are not quantitative inspections. These are qualitative inspections. The light colors areas on both thermal imagers and belts, pulleys indicate we might have an alignment issue, or we might have maybe a friction issue. And I think there's an interesting image here also. You can notice on the top right motor that there's a concentrated pattern of heat in the center area of the motor. I think it's a pump. When that indicates that there might be some issues with the stator, and it might be impacting the electrical insulation. Also, another application, key application in process manufacturing, which is process and operations. And thermal inspections are commonly used to monitor equipment capable of enduring high temperatures, right? In these segments, we've seen a lot of pain points in refractory equipment. We see that in assets such as in cement, verticals, or food and beverage. Heat signatures of failed refractories can tell us that we might have a potential problem. Also, solid levels, as I mentioned before, are capturable with the image. But and we're going to talk about this later. For specific assets such as tanks, and in order to detect solid levels, we need to have specific features and comply with some specs on the camera in order to see what we want to see, because we're at a large distance, we're outdoors, and the delta temperature between the liquid, the air of the tank, and the case, it's high. And here I want to show you also in the bottom right of the slides a cement application infrared image, which is a rotating kiln. And you see here that on the center area of the kiln, there's it looks to be a refractory issue because it's an isolated higher spike in temperature. And this is for R&D. Sorry, for cement. For R&D, and this is a non-conventional vertical for thermography, but the demand of cameras, it's increasing. R&D has applications that are not necessarily related to the typical maintenance troubleshooting, but more focused in quality and experiment outcomes. For example, I think I mentioned aerospace before. In aerospace, thermography, I think it's a pretty young technology. We get highly efficient for non-destructive testing for composites, right? And one of the typical scenarios or typical damage scenarios that can be seen through IR or thermography in aerospace, it's fuselage fatigue cracks, BVIDs, I think that's the way we refer to visible impact damage, the laminations, and before there were only two, I believe two non-destructive testing technologies before the adoption of thermography 10 years ago, which has been taking the cost down to perform these non-contact inspections. Here's an academic example of how to use thermography. It's highly used in geological research, in this case, eruption of volcanoes in Hawaii. So now that we have some baseline, we set some baseline around the fundamentals of thermography and what are the applications in the markets. Let's talk about the 7 secrets, right? What are the Fluke 7 secrets, 7 recommendations to have a best-in-class thermal image? And the first one, it's resolution. We're gonna talk about resolution for a few seconds. So the typical array for a model thermal camera ranges goes from 120 by 80 to 640 by 480 radiometric pixels. That is what we define as resolution, is the number of temperature points that the camera is capable to absorb and reflect into an image. So for specialized applications, there are some cameras that support resolution even higher than 640 by 480. We're talking about 1000 by 1000 resolution. And here the key thing to understand is that the better the resolution, this is equivalent to a better pair of thermal eyes. More radiometric pixels means more temperature points and more details on the image. Fluke has cameras starting from 120 by 80 to 1024 by 768 pixels. And depending on the applications, we also provide a functionality which is called super resolution that allows through software enhancement to duplicate the maximum resolution or the resolution of the camera. In the case of 1024 by 768, super resolution through software we'll provide to the end user double the resolution by software enhancement. And this is a very important functionality for high-end cameras in R&D, in utility segment transmission specifically, or even in pharmaceutical for biocompounds inspections. So the second secret I want to talk to you guys, it's IR fusion or fusion, right? Overlapping visual with infrared images. And fusion technology captures a visible light image in addition to the infrared image. And I define it as taking the mystery out of infrared because it overlaps visual spectrum images with infrared images. And here are 3 examples of a large acid, low level of liquid, fuse image, a motor, and an electrical panel. Fluke cameras, we support this technology, which is called IR fusion, and we support 5 modes of IR fusion in most of our cameras. The first one is full infrared, which is basically the whole image in radiometric mode or infrared mode. The second one is called PIP, or picture-in-picture, which is basically the overlap between the visual and infrared spectrum images. And the 3 images you guys are seeing here right now are PIP, or picture-in-picture images. Then we have a mode called blended mode, which is similar to PIP, but it allows us to control the contrast of the infrared image, having as a background the visual image. So that will help us also to validate that the image is properly focused. We have another mode called visible alarm, which is a mode that triggers an alarm in infrared mode on a visual image based on the thresholds or layers of temperature that we set. In the case of the center image of the motor, if we use a visible alarm of above 80 degrees Celsius, we might see in infrared palette mode this area of the motor, while the rest of it will be in optical or visual spectrum. And the last support mode that we have in IR Fusion, it's full visible, which is a full optical image, no IR graphic representation, but it's still an infrared image. So in the case of a full visible infrared image, it will be this tank image without the blending or without the palette showing temperature representations of a color with a color of temperature, but always in optical mode. Then the third secret I want to talk to you guys, it's very important actually. It's called focus. A quick, good focus. And focus is one of the most important factors in a thermal inspection. A focus image cannot be fixed through software once it's saved. A bad focus image, I mean. And this is critical to understand. We cannot improve or we cannot fix images with a bad focus. So that has taken us to the point at what are the tools that we have to focus an image. We have manual and automated focus images, but the key here is to understand that focus is so critical from an optical standpoint and from a measurement standpoint that an image that without an in focus image, our quantitative measurement can be as far as 20 degrees off, right? And also the image will look blurry and hard to understand or identify what are the assets that we're inspecting, despite knowing that from the end user. So we have 2 problems, right? Number 1 is the quality of the focus, and number 2, how to do focus, right? We have initially thermal imaging had initially manual focus incorporated, but an inspection where it requires a focus through manual mode, it takes around 10 to 12 seconds to actually focus through the rotating gear the image and then push the trigger, save it, right? That will take around 15 to 18 seconds. And it's a lot. It's a lot for utilities substation technician that takes probably 500 images a day, right? So Fluke is providing a new technology which is called laser sharp. And laser sharp autofocus allows to automatically focus the image by just pressing one trigger, right? So the camera, of course, will bring the manual focus mode, but laser sharp allows the end user to reduce from 10 seconds the act of focusing or the action of focusing to 3 to 4 seconds. So this has taken us from 18 seconds to the entire process of taking a thermal image, saving it and put it on the camera to from 18 seconds to 7 seconds, right? And autofocus, it's a key component here. And it's just a click, just focus on the area, click the black trigger of the camera, and you will see that the image will automatically focus in less than 2 seconds. There's another secret that I want to talk to you guys about. It's related to focus also, right? We talked before laser sharp, which is primarily a tool or a feature that allows the user to take quick images, right? Well, how about the quality of the images? How can we improve the focus? How can we maximize and have a best-in-class focus and a quick focus? And we're going to talk about the secret of focusing multiple targets at different distances, right? Focus distances impact the overall quality of an infrared image. That's something that is very important to mention. And one of the big problems that we have seen in the market is customers trying to achieve perfect focus, which means have all the objects inside the field of view in optical focus. And we have seen problems of having the entire picture in the field of view on focus when we're inspecting objects that are separated by a fence, maybe, or by an object that has some disruptive areas. And we solve that by incorporating to our cameras a new technology called Fluke Multi-Sharp. The technology allows to have a full focus image through the trigger, through the black trigger that I mentioned in Laser Sharp, but it also allows to have in the entire field of view all the assets focused. And what is the secret behind? The camera's just taken multiple images in less than a second and combined them all. So we're sampling the entire surface, the entire field of view with different images. They are differently focused, right? And the overlap or the combination of all these images will provide a full radiometric focus image. So not only we're providing a quick way to focus through autofocus, but we're also providing a way to have a perfect focused image. The next secret I want to mention to you guys, the fifth secret, it's very important actually. It's the UX or the user-friendly interface, right? We can have a camera with a good resolution, best-in-class focus, but if it's not user-friendly, it won't take us anywhere, right? At the end of the day, we want to do a high quality, quick, and easy to use inspection that will save time to our customers, right? Let's spend some time here, right? Because UX doesn't mean visual interface on the camera. It doesn't mean the firmware representation on the LCD. UX means how to save, what is the form factor of the camera, how to take the image, what is the tangible and the untangible interface of the camera that the customer is interacting with. And it's also the type of screen, the weight, the center of gravity, and I think I mentioned before the form factor. And our Fluke cameras have two types of form factors. We have the handheld gun form factor and the articulated form factor, which is the one that we're showing here in this image. We have seen through voice of customers that users, they don't like to, they struggle by interacting with the camera while using safety gloves, right? It's hard for them to press some buttons. They don't calibrate the force of the fingers when pressing a button joystick gear. And what we did is that, so first off, we generate two form factors depending on the applications, right, in the market we're serving. But also, most of the cameras that we are selling right now, they have responsive touch screen for multi-touch operations. We also incorporate independent keypads with calibrated sensitivity. So the clicks allow the customer with heavy duty electrical safety gloves to properly press the button without the need of pressing it too hard or pressing it too soft. And we're also providing a best-in-class screen, right? A best-in-class touch screen, which is crack resistance and tiny glass that allows to see the image despite having behind a heavy source of illumination, which in this case, in outdoors applications, the sun. So UX is critical. The sixth secret I want to talk to you about, it's becoming more and more popular these days, and it's software integration. Software is very powerful, and it's not only, I don't mean software, the firmware of the camera, I mean the PC software that comes with the camera. And with software, we not only can process and open the IR images in our desktop computer, but we can also manipulate them and improve them, all the images that we save in our camera. And we can do that by change all the parameters that are set up in our camera. We can change them also in the PC. So we can change the palette color, we can change the emissivity, we can change the transmission factor. we can actually even change the manual versus auto mode, set it up on the camera. There's only one thing that we cannot change through software, and I think I mentioned this before, which is the focus. So it's critical that we have a good focus, and I think we mentioned this in secret 2 and 3. And within the software capability also, what better than a clouded solution that will allow us to manage data, and in this case, images, incorporate these infrared images with other measurements with different assets or different tools from Fluke or other families, right? Incorporate a thermal image of a motor with a power quality analysis done with a multimeter, with a power and a clamp meter, or with a full power quality analyzer tool. And we can do that through Fluke Connect. And all our cameras have both Wi-Fi and Bluetooth capabilities that allow to upload the images to our portable devices, whether it's a cell phone or whether it's a tablet, and then scale it directly to the Fluke Connect cloud. And then last but not least, the 7th secret, it's called, I guess, let's call it expand functionality of the camera, but we talk about resolution, we talk about focus system, we talk about fusion technology, but we forgot to mention a critical feature, which is optic, right? And depending on the applications, we might consider the field of view, right? In the field of view, what we care about is to see the maximum amount of critical information in our field of view of the image, right? In this case, if we're outdoors and we're doing a transmission, an inspection on a transmission line, we want to have in our field of view the entire area of the transmission antenna, the high voltage transmission antenna. And lenses here play a critical role. And we're going to talk about lenses right now. Lenses have a huge influence right now. And across the market, the typical type of lenses that we can find are wide angle lenses, telephoto lenses in different scales. But a key comment that I want to make here is that lenses require calibration when they're adapted to a thermal camera. And our lenses, our Fluke Smart lenses, do not require calibration when inserted. Once they're purchased, they can be easily adapted to our whatever's the camera we're using. If it's a TI 300, 400, or a TIX series, they don't require upload any type of firmware through SD card. They are just plug it and good to go. And we have 2 types of lenses. We have, well, actually 3. The cameras come with a standard 20mm lens, but we also have telephoto lenses, and we also have wide angle lenses, which are pretty popular in indoors applications on the utilities vertical, also in the oil and gas industry when inspecting large assets, such as I mentioned before, oil or refining deposits, tanks, primarily to detect or to inspect the level of solids in the tanks before jumping into an overhauling or a stopover. So within that, I guess what I want to wrap up here after presenting the 7th secret is, what is our application? What are the typical size of the objects we want to inspect? What are the typical distance of where you want to inspect? And what are the temperature ranges in the scene? These are 4 critical questions that we need to ask ourselves before buying a thermal camera. And what is thermal camera that we recommend? So we have 3 different families. We actually have 4 families. We have one family that is called visual infrared thermometers, and these are digital. We call it infrared thermometer, but they're not really thermal cameras. But these are very popular in the HVAC market, where accuracy and resolution are not critical, right? But for the thermal cameras, industrial thermal camera family, we have 3 series, right? And each of them have different price points depending on the specs. We have the performance series, which is very popular in the low-end utility segment in distribution primarily, and also in the HVAC market. And this is used as a troubleshooter. From my experience, I've seen this camera, it's the perfect IR troubleshooter. Then we have the professional series, which is our most popular camera. And this is a troubleshooter / specific domain application camera. This camera is very popular in utilities, it's very popular in oil and gas, and it's a bundle, right? It's used as a troubleshooter for heavy industrial facilities maintenance, but it's also used for specific applications. And this is due to the high resolution provided, combined with autofocus or multi-sharp and the Fluke Connect capability, right? And the last, and I would say the best in class thermal camera series that we have, it's the Expert series. And we're talking here about cameras from 320 to 240 all about to almost close to 1 million pixels, radiometric pixels. And these cameras are very popular in the R&D segment, in the electronics and semiconductors industry, and also in utilities. They're very popular in the outdoors large distance inspections. And these cameras come with a articulated form factor, dedicated LCD. Also, they're all Fluke Connect, and they have the usual add-in capability of telephoto or wide angle additional lenses. So before we dismiss and we jump into Q&A, again, we appreciate George and the T Equipment team to have us here. If you have any of these questions, please feel free to contact T Equipment. We appreciate again them for having us in this webinar. And I think at this point, we're gonna go through a Q&A section, George, correct?
Do we have some questions from the people online that either Marco or I could help you with and be able to answer? I guess I can speak to a couple of common questions, Marco. And one of those is training, right? If you think about a lot of facilities, they may be very familiar with thermography and call in a thermographer from time to time to run some routes and to make the thermal scans on different components, different devices. But the question becomes, if I want to get started, I'm fairly new to thermography, I want to get started, I buy a thermal camera, then what? Obviously, there's a science, and in fact, there's the science that drives all thermal cameras and the ability to get a good measurement. Similar to what Marco was talking about, focus and focus being so important. And the reason is that thermal, this is a receiver for thermal energy. And through the lens system, that focuses all of that energy in a pinpoint on top of a microbolometer. And the microbolometer is the detector actively inside the thermal cameras. And this will focus that energy at that point. So you want to make sure that you get good focus, but that's part of the science that goes into this. Fluke provides a wide variety of different training options, all the way from different application notes and white papers, quite a lot of videos and a lot of studies on thermography, as well as links to be able to go through a professional series of different levels of certification and training. So I just thought I would throw that in.
Thank you, Corey. Appreciate for the comment. I see here a question from the audience. What are the cost of your lenses? So we have. Let me start from saying that we have 7 different lenses. Actually, no, we have 10 different lenses. Our family, it's basically, as I said before, we have telephoto lenses and we also have smart view lenses, but they all differ in the capacity of the lens. So the most basic lens, which is the wide angle or the telephoto lens for the TI 400 family, the price point is, I believe it's $999, $1,000. And prices change upwards depending on the type of camera and the type of lens that you're using. For example, and I think I missed this, we also have macro lenses for R&D applications, and these are lenses for specific models of cameras, which are the Expert series cameras, the one on the extreme right matrix that I mentioned to you guys on the cameras family explanation. And those lenses they're going close to $6,999. So again, it depends on the type of lens that you want and what is the camera that you're using for these lenses. And the price band again, it's $999 all the way to $7,000.
And something to keep in mind, the lenses are obviously highly critical depending upon the application. If you're an R&D and you're looking at microelectronics or micro research, that takes a lot of technology to get that level of focus and accuracy and resolution in through that lens system. This is not glass, it's a special material that allows thermal energy to pass. Glass is actually reflective to thermal energy. So people, I've seen in the past, people want to protect their investment and they put potentially a glass camera filter over the end, and that defeats the whole purpose. So you cannot do that. These are specially designed and specially engineered to work with our thermal imagers.
Thank you, Corey. George, I don't know if we have any other questions from the audience. So it looks like Jorge is having some audio problems. So if we don't have any questions, I'm seeing the only question that came was the cost of the lenses. I want to appreciate all of you to join us. Again, we want to thank T Equipment for having us. And if you have any other questions at this point, you got the information from Jorge, and I think you have also the information from Fluke at the beginning of the deck. So again, we want to appreciate you. We want to appreciate your attendance to this webinar, and thank you very much.
Thank you, everyone. If you do have any questions that come up, definitely you can get with us. We'd be more than happy to be able to answer those for you. Thank you.